So let's see. First thing we did was, well, quadrilaterals. Immediately slid that up there.
You can still see the
Yeah, shut up.
shape.
So the quadrilaterals, such the nicest person, aren't I?
You are. Trying to get his cry.
Nah.
Every other.
What makes a quadrilateral a quadrilateral? For what?
Any sides or
Four-sided figures.
yeah. Just
So quadrilaterals start out as your plain old boring four-sided figures. Nothing crazy about that at all. From that, we started to talk more and more about specific ones, more special cases. And the first one we talked about was the parallelogram. We started talking about the parallelogram. And within the parallelogram, there were a whole bunch of properties. Like,
there's one side there.
you just kissed your paper. I think my day is done here.
Door's right there.
Yeah.
Why did she have to kiss the paper?
Why did that?
Did you just tell me to talk to the hand?
No.
Are you sure? Because you went, I didn't have to tell you what I'm talking about. I think I just got talked to the hand.
Just go over about
Thank you. You're right. You are a very optimistic person today. I appreciate that. You said it's a beautiful day. I hope your day is wonderful. Don't judge. You're telling us to stay on the straight and narrow.
I try.
You don't just try. You do. Shut up. All right. What's one thing we know about a parallelogram? Don't say four sides or I will throw something at you. Don't talk.
There's something you're supposed to throw at.
How about this? Opposite sides are parallel.
No, they're trying. I'm really pretty today.
After we know that opposite sides are parallel, what else do we know?
The other opposite side are parallel.
What's that? Opposite angles are congruent. Good, let me slide this up a little bit. Opposite angles are congruent. What else? We know that. We know that.
They're same, the opposite sides are same.
We call that
Congruent.
There you go. Opposite sides are not only parallel, but they are also congruent in a parallelogram. Two other things. What do you got? No, I have not. Yep. Consecutive angles are supplementary, which means they add up to equal how much?
180.
180, good. And there's one other.
Oh, don't they have like the
They have diagonals, but what's more specific about the diagonals? Yes, ma'am. They bisect each other. Other shapes have more specifics, but we know that the diagonals in a parallelogram will bisect each other. So as being a parallelogram, you will opposite sides parallel, opposite sides congruent, opposite angles congruent, diagonals that bisect, and angles that are next to each other always add up to equal 180 degrees. And that makes you a parallelogram. All right? Now, after we talk about parallelograms, we switch to the two other types of them, the rectangle and the rhombus, and they each have their own properties. They still shared everything of a parallelogram, but they had other things that made them more specific. For For example, what makes a rectangle more specific than a parallelogram?
490-degree angles.
It has 490-degree angles, correct. What makes a rectangle more specific is that it has the 4 right angles. By having 4 right angles, it still means that the opposite angles are congruent. It still means that the consecutive angles are still going to be supplementary. That also happens. It just so happens to be the same angle then. What else makes a rectangle a rectangle? We know that the opposites are two sides and all that stuff still congruent because it's a parallelogram, but there's one part of a rectangle that's more specific. We already have that.
Right triangles.
We have those already thrown in, but how do you create the right triangles?
With X and U.
Right. We have the diagonals, and since it's a parallelogram, the diagonals bisect each other, but more specifically, the diagonals are what? They're equal to each other. So the diagonals are congruent to one another, which means that you get 4 congruent chunks, and that's where you were headed towards. Okay. You have the 4 congruent parts of that. Okay. That's what made the rectangle more specific than the others. After that, we talked about the rhombus. Well, again, the rhombus is still a parallelogram, so it has all the properties of the parallelogram, but it has other things that makes it more specific. What makes a rhombus a rhombus?
Angles do.
What do you got? The diagonals are perpendicular. Very good. Diagonals of a rhombus are always form right angles. Diagonals of the rhombus always form right angles. Diagonals of a rhombus also does something to the base angles. What did it do? Yes. It did what? Yes, they have 4 congruent sides, and Evelyn, did you say what they did to the angles? Somebody, yeah. Remember, the diagonals of a rhombus, they bisect those base angles. You still have opposite angles that are congruent to one another in a rhombus because it's a parallelogram, but more specifically, those diagonals cut each one of those angles into 2 equal parts. So a lot of times what I do is I just kind of draw it with the tick mark going through both of them so that they wind up being ticking the same. Excuse me. Yes, ma'am.
You're more more little extras to draw.
For what?
For here, these things. You gotta draw lines here and here and here, right?
You are correct because the diagonals still bisect each other, but it doesn't mean because it's a parallelogram. But it doesn't. It's anything more specific of a rhombus than it is a parallelogram. If that makes any sense.
Yeah.
All right. So really, all that happens is you get that. You get those extra parts. Now, the granddad of them all, if you will, is the square. And the square has all the parts of everything. The 4 congruent parts, or sides, the 4 right angles, the diagonals that are congruent, the right angles in the middle, the bisected angles, and so on. Do you guys remember what trapper keepers were? A trapper keeper? No, but what is it? No, please. Okay. A trapper keeper, just got a regular 3-ring binder. Actually, there's one. A trapper keeper, and I just noticed you had a computer that I didn't want to accidentally open it up and drop it. So a trapper keeper, back in my day, was like the coolest thing that you could ever get because it was a 3-ring binder that had a flap that kept it like kept it shut. So it was like a little Velcro piece. But the Trapper Keepers weren't just born in white or blue or black or red. They had like awesome prints and cool stuff on them. And you could, I don't know, whatever. But you could make forts like that because when you take your binder, you take your binder, sometimes the binder doesn't balance very well, but of course yours balances perfectly fine. But sometimes with the Trapper Keeper, by having that extra third side, you get an extra wall. You can hide your stuff from people, like Mr. Snow's doing. Try to avert his eyes from Miss Taupe, so she doesn't turn him into stone. Yeah. That's what we did too. I saw that and I thought of back in the day of a Trapper Keeper.
Yeah, this was the cool thing to have.
A pen.
Yeah.
Yeah, it
Oh,
was.
man.
Everyone would be like, yeah.
My dad used to pencil like this all through high school.
Anyway, so you got this. The non-parallelograms. There were two non-parallelograms that we looked at. One of them had something more specific than the other, but they were both pretty straightforward. What was one of them that was a non-parallelogram? A kite. Sure, we'll start with the kite. The kite. When we talked about the kite, I always said to treat it like it was two isosceles triangles put together. Treat the kite as two isosceles triangles that share a common base. That common base kind of plays the role of a diagonal. That diagonal connects the two different angles that would be congruent within the kite. So what I mean is, this would be the common base for both of those two triangles. That seriously, that means
What happened? I burped. Manners.
Hey, for your sake, at least you didn't fart.
She does that all the time. No.
So, can you tell where it's kind of getting to the end of the day at this point on a Friday? We're all like, yeah, whatever. So, when you have the kite, you've got the one base, if you will, that connects the angles that are congruent. That diagonal is always perpendicular to the other one. It creates the right angles, and it becomes bisected. Okay? So you get that little bit of information from the kite. As you recognize or you saw yesterday, hopefully in the homework and whatnot, that a lot of times you're dealing with kites, it's just a lot of Pythagorean theorem on the outsides and some very basic right angle stuff on the interior. Okay? Shouldn't have been anything crazy. The other two shapes then were the trapezoid and then the isosceles trapezoid. So let's distinguish between the two. Can I go to a clean sheet?
Yeah, you must.
Just making sure. So you have the trapezoid. The trapezoid had exactly one set of parallel sides, and that was about it. I did mention to you guys about the idea that you've got two parallel lines cut by a transversal twice, if you think of it. The two sides of the trapezoid that connect the parallel parts, those kind of act as a transversal. That means those interior angles on the outer edges, the ones that would touch the parallel parts on both sides, We're always supplementary. And I think that's really the only thing we ever wrote out about these. These two are supplementary, and those two were supplementary. And I think that's all we wrote about the regular trapezoid, if I'm not mistaken, correct? I think so. There's really not much else to it. All right. The isosceles trapezoid is the one that had, yes ma'am? This set of angles and this set of angles are supplementary. These two are supplementary. Those two are supplementary. They're not necessarily congruent at all. They probably never will be in a basic one. They just, because you've got two parallel lines with the one transversal, the consecutive interior are always at 180. What's that? Are you saying my handwriting's poor?
Yes.
We have an empty seat somewhat closer if you'd like. And then the last one was the isosceles trapezoid. What made the isosceles trapezoid special? It's isosceles. Thank you, Captain Obvious. Way to go. Could you be more descriptive?
It's a trapezoid.
Okay, Lieutenant Lamo.
Wow.
Wow.
Using more
You asked for more description. Gave it to you.
Isosceles trapezoid, just like an isosceles triangle, has congruent legs. Now, the legs of the trapezoid are always the ones that are not parallel to one another. And then it also states that you get two sets of congruent base angles. Two sets of congruent base angles. And there was one other thing with the isosceles trapezoid. Not perpendicular, they're just congruent. Correct. The only other thing with this was the diagonals were congruent. So let's do this. Let's figure out this handy dandy chart. Which means I don't want you to write this down because I have it on a piece of paper for you. So
Thank you.
so if you give me a second, I will pass that out.
Why?
Thank you.
Oh, no.
Thank you, though.
I'll go for you too. It's all right. Didn't like drop it into anybody yet? It's still early. So what I have for you guys coming up right now, it's basically, guys, what I'd like you to do is to go through the checklist and just mark off what has what. Okay? Let's check it one. Hey, you guys just don't like her. You should be. No. What I want you guys to do, first of all, put it in the last column. I want you to put isosceles trapezoid. Make another column for the isosceles trapezoid, please, on the all the way to the right. And then just take a couple minutes and check off which shape has what. We'll check it in about 5 minutes, but I just want you guys to mark them through. Quietly go through it and see what you get. I will create a better, cleaner chart here.